Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you. Amino acids are the basic building blocks of life, and I know firsthand how critical it is to stay healthy. Therefore, I've been on the lookout for quite some time for something that's 100% science-backed, that could both help with strength, cardiovascular health, and active aging. That's why I'm so happy I recently discovered Life from the Amino Company. Life is a patented blend of essential amino acids that works to improve strength, heart health, and overall quality of life, so you can stay healthy and active as you age. It's an easy-to-use powder that you mix with water for a delicious drink that keeps you healthy. You can check out their science by visiting aminoco.com/genius. That's spelled AMINOCO.com/genius. Use coupon code GENIUS for a 30% discount at checkout.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Robert Cohen. He's the president of Digital Robotics, and we're going to talk about his work with robots that are used for surgery and going a bit into his background and his current work. So, Robert, thank you for coming.
Thanks for having me.
If you would, tell me a bit about your background. How did you get involved with robotics?
So I'm a mechanical engineer by trade here in New Jersey. Went to college at the New Jersey Institute of Technology in Newark and did my graduate work in collaboration with the University of Medicine Dentistry. So I got to see medicine. I got to see healthcare. And I just thought of the world at the time of orthopedic implants was so exciting. This was back in the 80s, and the business and the industry was growing dramatically because total hip designs, total knee designs were all in total joint reconstruction. We're all starting to get better clinical results, and more people, population wanted them. And I've stayed with that business, since that day. So anything musculoskeletal, Richard, there's a joint in your body, whether it's shoulders, elbows, spine, total hip, total knees, ankles, things like that. I'm your person to make a piece of metal and plastic to replace it. But as we slowly evolved and the demand on implants has gotten greater, that demand on implants has actually required now a higher demand, not only in the implant design, but a greater partnership with companies like Stryker and the surgeon on where exactly should that implant go in that person. Your knee is totally different from my knee, and get into that world of individualized medicine and regular conventional instruments, saws, drills, cutting blocks. That wasn't taking enough information on the patient to make it that specific with some accuracy and precision as to where that implant needed to go in you. So the idea with the robot was the robot can be the most accurate and precise and execute that surgeon's plan specifically for that individual, which for us would make the implants actually function better and you have a more satisfied patient. So that's a long story of how it started with implants, but it's still about the implant. This is just about getting the implant in a better spot.
Yeah, quick question before we move on. So I see a couple of areas of customization. First, the shape of the implant and the size itself. But then I know everyone's, biology looks a bit different. People's livers are different sizes, et cetera. So is the robot looking at the actual tissue of the person and reshaping the implant to fit that person's, geometry and how their tissues lay? Or is the robot just doing the surgery in such a way that it'll be less invasive and impactful to the person based on, again, the geometry of their body?
Yeah, it's a different perspective. So quite often, and by the way, just to put this out there, people get confused when they think of medical robotics. So this is not like a Da Vinci robot that a lot of people know. That's a soft tissue robot. The robot I'm talking about for total joint reconstruction, that's a hard tissue robot. So it's got a saw and it's got some other things on it. And the objective of the robot is to get the implant in a more specific location, but also execute the bone cuts to receive the implant. So the final location of the implant is in the correct orientation. So therefore, right now it's taking the existing procedure that's manual and, if you will, robotizing and making more accurate that procedure to hit a target better. So it's not necessarily about less soft tissue damage, although this does provide less soft tissue damage because of haptic control. But it really is about specifically getting an implant more accurate where you're needed and where it's needed. So how does it do that? It doesn't do that necessarily by looking at tissue. Again, we're replacing bone here, not tissue. It starts off with a CT scan of you. So the CT scan at some imaging center would be of your specific knee. I'll just keep using total knee if it's okay as an example. So we would take that CT scan, which are a lot of segments, right? A lot of different layers. Surgeons provide us that CT scan on the patient, and we, as a service, convert that CT scan into a virtual three-dimensional model, bone model of the patient. You can't get better than that. Then, now that we have a true representation of that individual and all the bone and anatomy differences, we then take virtual computer models of Stryker implants, total knee implants, and superimpose it over the bone to reestablish a patient's joint line, to look at how their knee would be while they stand and while they sit, flexion, extension, and fine tune it that way. So the surgeon is starting with a much better place because you use three-dimensional imaging, but then also the surgeon can fine tune it intraoperatively by working off a real virtual model of that real person's bone.
Yeah, it sounds like you get a lot closer fits and a lot better actuation of them in use.
Yeah, without a question. And this doesn't take the surgeon out of the surgery, by the way. Surgeon is still making the final decisions. We just provided a different tool to execute the path of the surgeon. I presented just a couple of weeks ago, and someone made this analogous to say autopilot. If you're going to fly, I'm sitting here in New Jersey, if you're going to fly to Newark to London, well, autopilot, what's the purpose of autopilot? You're not really taking the pilot out of the equation. But autopilot's getting you from Newark to London in the best way possible, and you're essentially hitting a target, London. This is the same way. The surgeon is still deciding where the final implant is. Stryker now, and me as an engineer, is providing that surgeon with a lot more information about the patient than they ever had before preoperatively. A lot better assessment we could do. But now, individualized medicine. Put the virtual implant models in a way that individual person needs it. Now Stryker's provided the tool called a robot to execute that plan, which is what the surgeon has agreed to and has assessed intraoperatively. So it really has made a remarkable contribution. There's never been an industry that a robot touched and the robot didn't benefit that industry. And there's never been a robot that entered an industry and left it. And orthopedics and hard tissue robotics will be no different. We are already seeing appreciable benefits from a robotic procedure in total joint reconstruction. And this will continue to evolve, and we'll see it go further into other areas of the body.
Are these implants hard and fixed, or are they malleable and soft? Are you cutting and putting in, let's say, a hard implant in such a way that it still can work better with the person's body? Or do you work with soft implants that the implant's morphology has changed to suit the person's body in the first place?
No, it's a really good question. It's a common question. No, these are off-the-shelf implants. If you look at a person, you may say to yourself, gosh, why not just replicate that human being exactly, right? Well, the people we're doing surgery on don't have healthy knees. Replicating anatomy that maybe was there at one time isn't how their knee functions now. So let's take arthritis. That's the number one reason we do. I'll just stick with total knees, but that's why we do a lot of all these total knees. People are in pain. They lost their cartilage. Well, when you lose your cartilage, your anterior cruciate ligament doesn't work like it used to. Your posterior cruciate ligament doesn't work like it used to. Not to mention your femur, your bone, has flattened and maybe the arthritis has created some of these bone spurs and everything else on it. Why replicate a bone which may not be the way you want the bone to be? So we've been more beneficial by saying, let's stay with off-the-shelf implants, but let's untether the location. Let's make the location with 6 degrees of freedom, go where that specific patient needs it. And then we know one thing. We know if we restore a person's joint line, so if you bend your knee exactly where that bending is occurring, you will have a better satisfied patient. You will have a patient with less pain, and you will have a patient that restores to motion. So we believe, well, we've actually now have enough peer-reviewed publications, 300 peer-reviewed publications, which actually support lower pain, greater patient satisfaction, earlier return to flexion, less use of opioids. So we've made already remarkable changes in a relatively short time by introducing a new technology, a robot, into the procedure without the need for expensive custom implants, without the need for restoring an anatomy to a pre-disease state, which may not be right for muscles, tendons, and ligaments.
Maintaining your strength and a healthy heart as you age helps promote healthy living and hence quality of life for all people as they age. To help prevent the natural decline of muscle and heart function, it's important to make sure you are getting the nutrition your body needs. And not just any nutrition, but science-backed nutrition, like Life by the Amino Co. You can take Amino Life as part of your daily normal routine to help maintain muscle mass as you age, maintain good heart health, and increase longevity. A recent large clinical trial showed that Life was more effective than even exercise in maintaining strength and physical function in older patients. Further, Life has been shown in clinical trials to clinically improve blood lipid profiles by reducing triglycerides, LDL, VLDL, and total cholesterol. Life is 100% science-backed and is designed for heart health and active aging, which are crucial for a total lifespan. Why Amino Co? Well, Life works by triggering muscle protein synthesis, which is the body's mechanism for repairing and building muscle. When tested against any other protein source, Life is more than 3 times more effective on a gram-for-gram basis at stimulating muscle growth and repair. I know just how important it is for my quality of life and staying healthy as I age. You can check out their science by visiting aminoco.com/genius. That's spelled AMINOCO.com/genius. I've been on the lookout for something that can help me support healthy blood flow and help preserve heart strength and function, while also helping me maintain healthy triglyceride and LDL cholesterol levels. Further, something that tastes great and is easy to incorporate into my daily routine. So if you're looking for a nutritional advantage when it comes to maintaining muscle mass and cardiovascular health as you age, I recommend you give Life a try. Don't forget, right now you can get 30% off with code GENIUS when you visit aminoco.com/genius. Plus, get a free gift with every new purchase.
So what's better about these implants once they're in place? What are some of the variables that you guys track or have gotten feedback on?
So the implant, if we link it back to the robot, right? So now before, we didn't really know where the implant was. You take a 2-dimensional x-ray after surgery, that's not giving you your total knee is a 3-dimensional thing, right? And so we never really knew exactly where the knee was. So when someone said they were dissatisfied, why were they dissatisfied? Well, hard to tell, right? And when someone said they couldn't get enough motion in their knee or they couldn't flex and bend their knee as much as they wanted to, even 2 years after surgery, why? Now what we've been able to do is to say, the implants are designed good. The total knee implants that Stryker saw, they're good knee implants. They've stood the test of time. This is more, if you place it more accurately where an individual patient needs it, can you get better performance out of the implant? And we track better performance by better stability. Here's good success criteria. If the implant is put in right, you have a greater chance of walking up and down stairs normal. You have a greater chance of getting out of a car normal. You could walk 1,000 yards in a mall without any pain. You may be able to go back to activity. It's not just golf and tennis. You may be able to do more activity, and you have an implant that may possibly last your lifetime. If you look at what I just said, people who got knees prior, there was a lot of variability to the placement of the knee in an individual. We stopped variability with robotics. That variability sometimes limited how much someone could bend their leg. It limited how much pain reduction they were going to get. it limited how much they were going to be able to walk and how much exercise and motion they were going to get in their knee. So we made a remarkable difference. And the remarkable difference, and one of the indicators is we can port out the final three-dimensional placement of the implant from the robot, because the robot knows exactly where to put the implant, and make a computer model of the patient post-op. How's that? That's fun. And then we can also say, okay, how do you feel at 6 months? How do you feel at 1 year and 2 years? And if that patient comes back satisfied and you get higher satisfaction ratings than, say, with a non-robotic procedure, you're winning.
Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up. And check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Right, but in talking to patients colloquially or anecdotally, what are they saying? What are they experiencing?
Patients are saying with the robotic surgery that they have less pain. They have pain that goes away faster in addition to less pain. And because of less pains, they're taking no or minimal opioids as we try to reduce opioids with that crisis. They're saying they don't need as much physical therapy because the knee is put in the right place. They're able to get flexion fast. They're able to return to work sooner. And in the world we're living, where all these outpatient surgery centers are popping up all over the United States and the world, that they feel confident with the robotic procedure, that they feel comfortable now with the consistency, accuracy, and precision going for outpatient surgery and going home the same day. So we're seeing a higher incidence of going home the same day from robotic surgery, patient satisfaction. But if you look at one of the indicators of Medicare, and a bigger indicator, have we reduced every total knee that was put in prior to robotics didn't work, right? Some were revised, some were maybe not put in as well as wanted, or there are other issues. So Medicare and the government track total knee procedures for a readmission rate and a reoperation rate. If you have to go back to the hospital 6 months, 1 year, 3 months out, you're now costing the healthcare system a lot of money if there's a complication from the initial surgery. It even costs even more money for Medicare if it needs a revision of the knee and another total knee implant put in that may be corrected what could have been a malpositioning problem. So from that perspective, lots of different KPIs, and the KPIs are successful. We were sitting at a place where we knew where manual joints were, and we knew what patient satisfaction, readmission, reoperation rate, economics, efficiency. We knew flexion. We knew what people were able to do at what decade of life. And in every single one of those KPIs, robotic surgery has improved it.
That's really great. When you say improved, I'm sure each metric improves at a different rate, but is there an overall percentage that can be expressed, or, how much better could you express this improvement to be? Like a little bit better, a lot better, unbelievably better, orders of magnitude? How would you express it?
Let's see, how do I answer that? So being an engineer myself and more quantitative, I could go with unbelievably better, but I'll try to quantify it for you. If you had a total knee 5 years ago, non-robotic, right? Because really robotic knees have only been around for 5 years. If you had it 5 years ago, we know the readmission rate, reoperation rate of total knees after 5 years was somewhere between 2 to 5%, depending on what hospital and what region, 2 to 5%. Now it's about 1%. Dramatic reduction, right? Dramatic reduction in readmission, reoperation. Let me give you one other indicator. Let's talk about patient satisfaction. That's hard to quantify because your criteria for success of your total knee may be different from me. But if you're satisfied, we're going to take that, right? If you looked at total knees 5 years ago, 30% of total knee patients were not satisfied. It doesn't mean they had to go for a readmission or reoperation. It just means maybe their leg wasn't balanced right. Maybe they couldn't get enough motion. Right. 30%. Now, if you get a robotic Stryker knee, 5%. the dramatic reduction, improvement in patient satisfaction. And then we've shown time and time again, this is it's a question that we can dwell upon because we as technical folk like to actually look through all these analytics. But the interesting part about this for us, which gives me the confidence to make such strong statements, is Stryker was in a fortunate position where the total knee that's being put in with the robot was put in manually before. So we have 10-year data on Stryker total knees that were done manually. And now we have 5 years of clinical data to actually compare the robotic knee to the manual with the same implant. So you're reducing variables, right? Same implant, same surgeon, same hospital. And we're able to see a remarkable increase in patient satisfaction. Remarkable increase in patient satisfaction. So that's real data. You limit the variables like that's hard to argue with.
Oh, that's really great. Good for you guys.
Thank you.
Now that you're at this point, when you look ahead, because entrepreneurs always look ahead, what's next? What other improvements do you see could be made to make it even better?
That is probably the thing that excites me so much. So the very first thing is just like you look at the robot as a piece of equipment that we provide in the operating room. If you think about it like your laptop, right? Your laptop that you're working off right now, your laptop, you probably don't need a new laptop in 2 years because you're not going to get a lot of features on your laptop. What keeps your laptop alive? New software. So we're thinking the same way with the robot. The robot we've designed, and by the way, we designed the robot, we programmed the robot, and we build the robot. It's truly a unique robot. So I'm very proud of all the people that work on my team and have been able to have such remarkable clinical benefits for people. So now the next step is how do you evolve the software for total knees and total hips? So we just released, actually this week, another generation of total knee software, which gives the surgeon more information on the patient, looks at the alignment of the whole leg now, the whole leg, not just looking at the little knee. Now we can superimpose and do virtual models of the whole leg to even fine tune this further. So software is going to keep evolving in the applications we're currently doing. Then next after that, we're going to do new applications for new areas of the body. So we have publicly announced, we have started on robotic shoulder programming. So for everything that the robots helped in knees and helped in hips, there's no reason total shoulders. People who get a total shoulder implant, there's no reason the positioning of that is very sensitive. And that's very specific to how you raise and lower your arm, how much strength you have, rotator cuff, all of that. We're excited and we started that brand new application. So we're working through that. We're also working through robotic spine. So looking at how if someone needs 1 or 2 or 3 levels of lumbar fusion, how can we get the curvature of the spine fused in a way that patient benefits it? And then we'll further go up the spine and look at scoliosis patients and have the robot position where the screws should be in the vertebral bodies of the spine to accurately replicate what's best for that patient. So now we have new software and existing applications. We have new applications that we're going after with new software. And then the third part, which is hugely exciting to me, is that we will now be connecting the robot to the internet to collect more data. In the world of population health, digital healthcare, think how exciting it would be that now if I could look at clinical insights on this from data that the robot provided. So let me give you an example. I'm just making this up. But let's say you're a 64-year-old female. Your BMI is 39. Your arthritis wore away 2 millimeters of bone on your tibia because your arthritis has been around for 20 years. Oh, and by the way, you're a diabetic. So good question, right? So now if I had 10 surgeons in the room, they may be treating that patient differently, all 10. One may say, this is the right implant for that person. Another may say, no, this is the right implant. Another person may say, hey, this is where this implant should go on planning. Another person say, no, I don't think so. Or someone may say, this patient's safe for outpatient surgery. And some other person may say, no, I want that person 3 days in the hospital. Well, all 10 surgeons can't be right. So now let's get all the data and more of the fine-tuned data. Look at electronic health records, do a profile of the patient, look at all the information we have on their virtual bone walls, look at what happens intraoperatively, and then ask patients to contribute to postoperative outcomes data. Now we have the continuum of care, and we can help with statistics, have surgeons query a database so they can look at that specific profile of that patient and what gives you the highest statistical significance chance for success. inpatient, outpatient, how long physical therapy, what implant to use, how to position the implant. Those are all exciting things that we've never had in the orthopedic industry. We never had that much data to look at. So this whole data journey is really exciting. The robot's a key missing link, though, because it gives us data of what went on in the operating room that we wouldn't necessarily have before. And now that we have these CT scan virtual bone models of individual people, we can look at population health in such unbelievable ways. That is probably the next remarkable short-term gain that we're going to see in healthcare.
Well, as you were talking about this, I was thinking with total knee, what if you did a gait analysis before and then, post-op, a month, 3 months, 6 months, a year, 2 years, et cetera, and you slowly build up computer modeling so that even before the surgery, if you did a gait analysis, you could even better fine-tune the implant because you kind of know through modeling what's going to be the resulting gait and, activity ability and all that of this particular implant on this person.
Yeah, really good point. And we talk about that often, and we probably will incorporate some form of gait analysis. The challenge with gait analysis, knowing what the person was pre-op doesn't really help us that much because we know we're going to make that person a lot better. Really, what matters more, are they loading their right and left leg the same way? Are they not leaning over and favoring one leg when they walk upstairs? Gait analysis helps there. Are they able to walk for a long time without changing their stride? And is the patient happy, right? So there's a couple indicators. But the gait analysis labs and things like that, but they're going to become quite antiquated. If you look at one of the things that even in the smartphones now, you can look at an image and the smartphones can actually tell with its camera. We have software now that can tell how good someone's walking at home. They don't have to go to a lab. Just put the camera on them and let them walk back and forth down their hallway. You also have now within phones between accelerometers and everything, you can now determine not only gait, but you can determine maybe where they are relative to the ground with positioning devices. And you can have these mobile devices. Stryker also has, and we recently acquired a company of sensors where you put a sensor that looks like a Band-Aid on your lower leg, a sensor that looks like a Band-Aid on your upper leg. You walk, the sensors actually talk to one another. And then when you go to sleep at night, there's a pickup station that's on the end table next to your bed, and it's extrapolating the data from the sensors. And we're able to do things. That way. So I think all that's important. I think it depends on to the extent we need the data. But also when we talk about data, you need to talk about data in a couple different buckets, right? It's not just how good someone was. We're talking more about improved outcomes, how to get better outcomes. But there's also the quality of care. How do you get greater consistency of the high end of improved outcomes? So you have improved outcomes, then you have the quality of care assessment, which is maybe a little bit different data or the way you look at the data. Then you have safety. How do you know these patients are not a fall detection? When should they not use a cane anymore? And then you have economics and efficiency in the operating room, economics, even for Stryker to reduce the amount of inventory, and all this data combined. So the gate could be part of it. It's not so easy to bring patients to these gate labs. More things and more that we could get at home will be at a lower cost. And if we do more at home, we'll probably have more patients participating.
How do you know, okay, so if you're working on something that someone has two of, a knee, shoulder, et cetera, is there use in looking at the less damaged or hopefully healthy other limb to see, okay, if we fix this for this particular person, their morphology and their action kind of looks like this, because the other knee is okay. So does that help you in your analysis?
Actually, it does. Sometimes we'll do that. Our challenge in motion, though, is someone has a bad right leg. They're still not going to walk correctly with their left leg. So it's just hard to know. So we do look at where their joint line is. We do look at their leg length. Because, by the way, after these procedures, if they're done wrong, we could shorten someone's leg by an inch, right? So we want to get their legs right. So we do, and we're going to learn more, and we're going to get better to use that type of data. The reason, by the way, no one did look the other leg, as you would suggest, is we had no way to deal with that information. It's only now that we have a robot that we can program that into, that we can deal with the information. So it is exciting, and the more data we have, the better.
Yeah, and there's compensatory patterns, which would hide what the real gait would be if both knees were healthy. Let's say if you're doing a total knee or shoulders.
Shoulders are a little bit
meaning
different.
like for if we stick with knee, like if my left knee has really been arthritic and getting worse and worse, there'll be a compensation on the right. So maybe a pre-op gait analysis or analysis may not help as much because again, how do you take out the compensatory patterns? Because after the surgery, that'll change or that'll hopefully go away.
Yes. Again, I would just like I said, some people just walk differently on their good leg because they've been compensating. So you can't necessarily take that as the gait that you want, even on the good leg after surgery.
Yep, makes sense. Okay.
Right. Yeah, because if your hip's hurting you like a son of a gun, right? You're going to be leaning on your other leg more, aren't you? And you're going to be walking up and down stairs and leading with your healthy leg. And if you had 20 years of arthritis, you probably have a cane associated with it, which made your everything wrong.
That's right. Yeah, it would keep pushing on the cane wielding, hand and shoulder, and you get all kinds of problems. Yep, makes sense.
Yep.
What kind of data are you getting from the actual surgery itself? You mentioned that in the chain of data. So what kind of factors can you look at later that would inform you based on what the robot did?
So right now, if you think about it, if I go through the procedure, maybe that'll help understand what data. So right now, let's say you're the surgeon and you see a patient and you probably took an x-ray of the patient. So that person's arthritis, total knee for sure. That surgeon will then send that patient to an imaging center for a CT scan. Once that CT scan is taken, that CT gets uploaded to the Stryker Health Cloud. On the Stryker Health Cloud, we convert it into a three-dimensional computer model of that person's leg. And then we do some planning to put where the virtual implants go on that virtual bone. So we have that data. So we have the CT. We know the patient. Because we're a healthcare company in the normal course of care, we know the age, we know identifiers, a few identifiers for the patient. And then a Stryker representative loads that plan onto the robot for surgery. And then we have the capability to start and look at the beginning of the case. And remember, the robot's tracking the time of the procedure, what steps, different screenshots that we have for the robot step by step, how long they were on each screen, the change of positioning of the virtual models based on the assessment of the person laying there, real time, what their bending was. And then the case is finished. So the robot, you refer to it as a session file. So then we can have a whole session file of everything that happened in that operating room. And that can get uploaded to Stryker Health Cloud, where it's attached, if you will, to the pre. So now we have pre-op information on Stryker Health Cloud. Now we have the intraoperative information on Stryker Health Cloud. And we do some clinical studies where we extrapolate some postoperative patient data, flexion, how long the physical therapy, what's their satisfaction. And that gets uploaded to Stryker Health Cloud. So we have, in some patients, preoperative, intraoperative, and postoperative data, and could put the whole continuum together. In most patients, we have pre-op and intra-op, which is an awful lot of data. But that's all in Stryker Health Cloud. Just to give you an idea of scale, since we keep talking about a robot, we're doing like 28,000 robotic hip and knee procedures a month.
Yeah, that's tremendous.
A lot of data.
What are there? Well, now that you're gathering all this data, what's jumping out at you that wasn't there before? Now that you have this additional data, are there new factors that you weren't even aware of that are important, to the health success of someone undergoing this surgery?
Oh, absolutely. In fact, now, if we just take even prior to the robot, being in the operating room, if we just look at the pre-plan, we have now looked at more patients' CT scans of an arthritic knee than ever has done before by anyone. And now when we look at the arthritic knee, we see the bone changes from arthritis in ways we never could see off x-rays. You need a three-dimensional bone model. We can look at bone spurs and things like that change over a period of time. We can associate it with age, and we can correlate age to how far progressed was the arthritis, to the amount of extra bone that grew. We can get to a point now on that data I just mentioned. We can give you a pretty good darn prediction of the time of the surgery. How long will that surgery take, and how complex will it be based on what we had? We never could have done this before. Now, even one step further. Now that we have all these cases and we do virtual models, we have to size the implants. We have many different sizes of implants. We are pretty darn good statistically now for picking the right size of implant for the patient. So just with this data that we never had before, now we can predict a patient's implant size, and we can predict the time of the procedure. There's an economic benefit to that. There's an efficiency, hospital benefit. If a hospital wants to maximize efficiency over what operating room is being used at what time, and wants to maximize the efficiency of that one specific room to try to get more surgery so they load it right, we can now partner in ways we never could have before. And now you go intraoperatively, there's lots of different ways to align a leg, a femur to a tibia. And as I said, all surgeons can't, be right for the patient. What's the optimize, right? So now we're starting to look at that and say, hey, this alignment fits this patient because look at the postoperative outcomes are so high. They're so positive. Why is that? And now we have enough data to go back and say why that is. And we're collecting more data on more patients, but we'll be able to do predictive analytics and eventually get into the world of AI to help the surgeon give you the best optimized clinical result for that patient.
That's excellent. Well, where can people find out more about your work, and if they're going to have a total knee, total hip, total, shoulder, how do they make sure that they request that it's it uses your equipment or it uses your robots or both?
Yeah, Stryker on our Stryker website. So Stryker, Stryker. So just go on the Stryker website. You'll see if you go under joint replacement, there's a Mako surgeon finder. So Mako is what we call the robot, and all surgeons that have the robot. But we're like in 33 countries right now, and there's a hospital near someone that has a Mako robot, and they'll list the surgeons associated that have been trained and certified on the robotic procedure. There's also, if someone looks under Mako, M-A-K-O, like the shark, Mako robot on YouTube, there's many YouTube videos that show how the robot actually works and how it's used even during a total hip procedure or total knee procedure. And it really is exciting. Even if someone didn't need to see a knee, but somebody is a technical person like myself, if you really want to see technology, in this case, a robot, and you want to see a robot sort of purposed for greater good, and if you want to see a robot that truly definitively made an impact on an industry and improved healthcare, this is a great example. I participate with many college lectures all the time, and I talk all the time how Stryker's been able to take a robot, program a robot correctly, individualize medicine to the extent for total joint procedures. And in 5 short years, we dramatically changed the market, but not just because it's a new toy, but we've actually now have definitive clinical results. We're making a difference, and a positive one at that. And this journey's not over yet.
Well, that's really great. It's been very interesting to have you on the podcast, and hopefully I won't need a total knee or shoulder or hip, but if I do, at least I can feel better, which is true. I do feel better hearing that this is out there. Looking forward to it, hopefully, again in the future. So, Robert, thank you for coming on the podcast. I appreciate it.
Thanks for having me. I appreciate it. Take care.
Before you go, if you're looking for a nutritional advantage, be sure to check out AminoCo's 100% science-backed life formula. It was created by lead scientist and co-founder Dr. Wolf. As a competitive athlete, Dr. Wolf has completed 62 marathons in under 2 hours and 30 minutes, set national age group records, and he's still running and fueling his body with life at age 75. I recommend you give life a try. It's 3 times more effective on a gram-for-gram basis than any protein source. The AminoCo is giving our listeners 30% off all AminoCo products, including Life. You can check out their science by visiting aminoco.com/genius and use coupon code GENIUS for a 30% discount at checkout. Remember, go to aminoco.com/genius and use the code GENIUS to get 30% off at checkout.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.